the lecture topic today is Max Faget, the ultimate spacecraft designer. Some of you may have seen in the newspaper that it did say that Max was going to be here presenting the lecture. One newspaper actually did print that. I'm sad to inform you that Max will not be joining us today. We did not have any success with the Ouija board last night in bringing him back for the lecture. We were pretty surprised when we read that in that newspaper. Like, oh, wow, okay. So, in any case, I will be giving the lecture today. My name is Chris Orwell. I'm the director of the museum. I always start off with a quote. So this one is from one of the NASA administrators, Sean O'Keefe. Without Max Faget's innovative designs and thoughtful approach to problem solving, America's space program would have had trouble getting off the ground. So Max was one of these folks who was central to much of the effort in the space program, the early days of NASA, pre-NASA, when it was the NACA, etc. And so what you're seeing here, usually our lectures tend to have to do with something that's going on out there in the real world, or the anniversary of a mission, or the anniversary of some piece of equipment, or something like that. This is one of the lectures, and I'm going to do a number of these over the next couple of years, that are about some of the individuals that are in the space program that you not necessarily have always heard about. Max is one of them. A lot of people have no idea who Max was. We'll be doing all sorts of these for folks: George Lowe, Max Faget, Gunter Wendt. We'll, just have some fun with all of this stuff. In any case, though, I think I've seen most everybody in here, so I'm gonna skip past my background kind of thing, and go straight into the lecture. Also, because I have a ton of slides. In any case. So another quote, this time from Chris Kraft. So history will remember him as one of the really great scientists of the 20th century. And truly he was. So we're going to start off a little bit, not with Max, but with a little bit of Max's legacy. So his father, his great-great-grandfather are the two that I'm really talking about here. The first one, Jean-Charles Faget, born in 1818, died in 1894. This was his great-great-grandfather, from the New Orleans area, was a doctor, and he is most known for what he found out about yellow fever. And what he discovered is that there was an indicator to whether or not somebody had yellow fever and then needed to have immediate treatment for yellow fever. And it was the fact that if you had a significant fever and you had what's called bradycardia, you may have heard of tachycardia, which is a really rapid heart rate. Bradycardia is a really slow heartbeat, less than 60 or even below. Generally, when you have a fever, you have a high heartbeat. If you have a fever and a low heartbeat, that was an indicator of yellow fever, and then they could treat it much more rapidly. So he was very well known, and that indicator was called Faget's sign. So in any case, though, medical history in his background. Well, then his father was Guy Henry Faget, born in 1891, died in 1947. He was a U.S. Public Health Service officer, which is why you see him in a uniform here. Generally, you'll see folks like that nowadays in like naval uniforms. Surgeon General wears a naval uniform, different insignia on the top, etc. But he was stationed at the U.S. Marine Hospital, the National Leprosarium. So what were they treating? Leprosy. So essentially it was a leper, place for lepers to go, and that's a picture of it down there in the lower right. It was in Carville, Louisiana. Not only was he running it, he was also doing research. So he was an administrator, he was also a researcher, he was a doctor, no surprise there. And he actually figured out that this promin and sulfoxone sodium combination could actually treat people with leprosy. He's the guy who figured out the treatment for leprosy. And so now you take a look at, so Max Faget now is eventually born. What do you think he's going to become? A doctor. No. Max took a slightly different route, but he had some significant history behind him. So Maxime Faget was born in 1921. He was born in the British Honduras, which is now Belize. So he grew up, though, in San Francisco. These are a couple of pictures right up there. That is actually the British Honduras, the main government house there. And then he grew up in San Francisco, and eventually, while growing up there, very much influenced. He and his brother used to build a ton of models. So he was a model maker. He loved to make models, mostly of airplanes, but also of submarines, which I really appreciate for obvious reasons. In any case, but he used to build all this stuff. He used to read tons of magazines, mostly, according to him, astounding science fiction. and things like that. You know, the magazines of that era, and talking about all the possibilities of what couldn't happen in the world of technology. So, in any case, he goes to City College of San Francisco for a little while, and then eventually transfers to Louisiana State University, LSU, there. And he's an athlete. He competes in wrestling. He competes in gymnastics. He's working on a mechanical engineering degree. When he went there, he wanted to be an aeronautical engineer. But the head of the engineering department essentially kind of talked him out of it and said, your better idea is to become a mechanical engineer because then you can do anything. He said, you can work in all these different areas, but get a Mech-E degree and then you can be useful just about anywhere. And eventually he does get in, obviously, to the aeronautics industry, but he is a mechanical engineer when he graduates. He graduates in 1943, middle of World War II. So, and volunteers for the submarine service. He gets a commission, so he is commissioned as an ensign. He goes on board the USS Guavina, which is under construction at the time. It was under construction from March to August of 1943. It was commissioned in December of 1943. And then heads on his way out, gets some final preps down in the south, and goes around and heads over towards Pearl Harbor. And starting in early 1944, the submarine goes on 6 war patrols. And so he makes 6 war patrols on board the USS Guavina as a junior officer. This is the Guavina as it looked during World War II. It was one of the Gato-class submarines. Pretty successful. Not one of the most famous submarines of World War II, but on every single patrol, it was successful at sinking tankers and things like the merchant ships and things like that. So in any case, this is what it looked like just before it was decommissioned. You can see kind of a radical difference in the sail, etc., because they had refitted it after World War II. Interestingly enough, on the 5th War Patrol, the Guavina took one of the most significant depth charge attacks of World War II. It had gone after and had sunk one of the merchant ships, and then the escort that was along with it and the planes that were in that area. It had to go down to the bottom in just 130 feet of water, and it bottomed out. You can actually put a diesel submarine on the bottom and have it sit there. In any case, 7 hours sat there while they dropped 98 depth charges on it. So managed to make it through. They thought that they had destroyed the submarine because it hadn't come back up. In any case, though, it did survive and went on to another war patrol, and then eventually was retired in 1946. This is a young Max Faget there, and that actually is him as the diving officer on board the submarine as well. So he gets out of the Navy in 1946 and is trying to figure out what to do, starts searching for jobs, and he ends up getting hired by the NACA, the National Advisory Committee for Aeronautics, out in Langley, Virginia, is where he ends up working. So the NACA, most people know, is the organization that existed before NASA, and essentially NASA absorbed it, and most of the people that started it up came out of the NACA. It was founded on March 3rd, 1915, so during World War I was when it was actually founded. So it was modeled after the European national agencies. There was a French one, there was a Russian one, German one, a British one that, interestingly enough, was called the British Advisory Committee for Aeronautics. Wonder where we got our name. So in any case, that's what it was modeled after. They tried to get it started in 1912 and 1913. And that actually, it failed that time. It didn't make it through Congress. And so what happens is when it was brought back up again, they did it a little bit differently, and they got much better support. They had the head of the Smithsonian pushing for it, FDR, who was an assistant secretary of the Navy at the time, pushing for it. And interestingly enough, it gets put in the Naval Appropriation Bill to create the NACA. The first rendition of it, 12 members. There's their first meeting. Not all 12 were there. In any case, but 12 members. They had a $5,000 budget, which we look at and go, oh, that's pretty small. Well, that's about $135,000 in modern numbers. So it was an okay budget, but for what they were asking him to do, not enough. But it grew relatively rapidly. So in any case, This was their charter, and this was actually what it said in the Act of Congress. It shall be the duty of the Advisory Committee for Aeronautics to supervise and direct the scientific study of the problems of flight with a view to their practical solution. Pretty good mission. So in any case, young gentleman here looking up at it as he walks into the building. So this is the first building right here that they built at Langley. So that was one of the original buildings there. There were other locations that developed over the years. They weren't all part of it originally. So you have the Langley Memorial Aeronautic Laboratory, eventually the Ames Aeronautical Laboratory, Aircraft Engine Research Lab, and then the Muroc Flight Test Unit. Muroc Flight Test Unit becomes Edwards Air Force Base, and it's located at Edwards Air Force Base originally. And then you've got Cleveland and California there for the other two as far as locations. This is one of the meetings that they were having. In 1934, in this situation, it was, and you can see gigantic wind tunnel that they had built here. So with an airplane that would have been for testing at that time, and these were all the folks who were at that committee meeting. In any case, though, in this situation or conference, excuse me, not committee meeting, but this conference, interestingly enough, in this picture are Lindbergh and Orville Wright, so who were there at that conference. So the tunnel here, you can kind of see, some of that here. You see a smaller wind tunnel with one of the rocket/missile/drone being tested on the inside. So into tons of stuff as far as aviation, then and eventually also into rocket propulsion, etc. One of the things, when you think about it, that the NACA, in working with Bell and working with the Air Force, but the NACA was responsible essentially for the X-1 program. We're not going to go in detail to any of these programs, really. Here's a bunch of the aircraft later on that NACA was working on. You see one of the X program planes right there out in front. That's at Ames. Eventually get into rockets and missiles and beyond airplanes. Originally they're working on airplanes, in the 1920s, 30s, 40s. Then they start working on rockets as well in the 40s and 50s. This was a preliminary study of manned satellites. Manned satellites. So in other words, here we're not starting to talk about human spaceflight. And so they were doing research on that as well. This is authored by Max Faget and a couple other folks, Benjamin Garland, James Buglia. So they are working on human spaceflight before NASA even exists. And they're working on it before we really even started truly pushing towards a human spaceflight program. But they're trying to figure out the issues involved with it. Another picture of Langley. There's that original building. It's early on. So when he gets hired on working with NACA, Max originally starts off with the Applied Materials and Physics Division. And so that's what he's working in. He's working on rocket propulsion, beginnings of supersonic flight. Remember, he starts off in 1946, so post-World War II. Jet engines, rocket engines existed very obviously at this point in time. And so research is going to be being done on those things. So he's working on that. Supersonic flight. Wind tunnels, they were working on testing all of these concepts, whether it was rockets, missiles, supersonic aircraft, engines, things like that. They had to test them out in wind tunnels as well to see, to get an idea of how they would work in the real world. And a skill of his came to play at this point in time. Remember those model building that you used to do as a kid? He was a really, really good model builder. So when they're building the models, he's helping work on them, he's helping design them, he's helping build them. So that kind of brings him to the attention more of some of the folks, and then he's also put in charge of some of these ad hoc projects with small groups, and he's in charge of those. So he very kind of rapidly moves up through the organization. Then he gets picked up by the Pilotless Aircraft Research Division, PARD, which is run by Bob Gilruth, who you may know that name also from NASA. Ends up heading the Manned Spacecraft Center. He becomes head of the Performance Aerodynamics branch of PARD. So there he's working on high-speed aerodynamics and heating for like ballistic missiles, re-entry systems, warheads, things like that. Ramjets, working on Mach meters and other ways to tell how fast or how well an aircraft is operating. Because not only are they figuring out can the aircraft fly, but you're also trying to figure out how do you measure the speed of these things flying through the air. The Mach meter, he essentially, created a Mach meter. So at least he has a patent for it, I'll tell you that. So then in 1954, he gets put in charge of working on the X-15, working on trying to make it fly essentially twice as fast, all the way up to Mach 15 was what they were looking at, higher, farther, faster. And so as they're working on this, they are really having to take a look at the heat loads and the heats that are generated on the aircraft. And you can see here a model of the X-15 in a wind tunnel test, and you can see the laminar flow off of it, et cetera. And really taking a look at, as this aircraft flies really high, really fast through the atmosphere, what are going to be the heat loads created on the tip of the aircraft, the body of the aircraft, the wing tips of the aircraft, et cetera, et cetera, et cetera. Because that's going to become very crucial. And as they're working on that, one of the things that they end up noting is that this pointy end operates very differently than a more blunt end at the end of the aircraft. And this has been being looked at not just in this program, but in other areas that NACA's work on as well. In any case, though, H. Julian Harvey Allen is really the one who figured out this blunt body theory. So blunt body theory, essentially in this situation, is the idea that when you have a pointed object, something very sharp flying through the atmosphere, and you're going supersonic at that point in time, you get a shock wave on the front of the aircraft. The more pointy the object, that shock wave is right on the tip. But if you have a blunt body, you'll see here the shock wave is right there. With a blunt body, it's detached. The shock wave is detached. It's out in front of it. So why does that matter? Well, the heat is generated essentially where that shock wave is. More heat is generated where that shock wave is. So the tip of this has to be protected against that heat load. Much, much, much more than this, where that shock wave is out in front of it, not right up against it. Yes, there is still going to be heat loading on it, but not as much because of the detached shock wave. And so that concept comes into play because at this same time, not only all of this kind of is all happening in parallel. So it's difficult to give it in really a series lecture. In any case, though. So as they're starting to take a look at a manned spacecraft, originally they're thinking, we need to have the Buck Rogers rocket plane kind of thing. Nice pointy tip so that it flies nice and neatly through the atmosphere. And when it's coming back into the atmosphere, it'll get more lift, et cetera, et cetera. Whereas they start to figure out, and really, Faget is one of the ones who's truly figuring out, if you're going to bring this spacecraft in, if you have a blunt body here, and you bring it back that way, you'll get significantly less heat load in here, less shielding, less weight necessary. You also don't need as much control mechanisms, etc. if you design the spacecraft the right way. You can save a lot in weight with this, and as anybody knows who talks about spaceflight, weight is one of the key elements to it. The lighter you can make something, the better it'll be as far as spacecraft is concerned. So here's just some of the project kind of things, looking at different shaped bodies. This is some of the missile nose cones that they're working on. Remember, this also would apply to missiles and re-entry bodies, i.e. nukes coming back in. So this has a military aspect to it, truly. As well. And then here you start to see the initial concepts of a manned spacecraft, and that shape ought to look a little bit more familiar to what we're used to nowadays. And there's kind of a Mercury capsule shape being tested. So what he figured out, Faget, once again, a one-man blunt-ended capsule-type spacecraft. It minimized the requirements, so you didn't need as much guidance, because once again, in this situation, you're truly not guiding it once it starts to go into the atmosphere. You can guide it before it comes in, but once it starts coming in, it's just on its own at that point in time. But then you don't need as much, as far as control systems. You're not going to be piloting it back to a landing. You're going to bring it in and parachute it down. So you don't need all the control systems to fly through the air. If you don't need things to do this, and on your rudder and stuff like that, and all the associated equipment, all of that weight goes away. So you don't need that. With the autopilot systems, you're not going to need to have those. You can get rid of the autopilot system. Controls the heat shielding for it. You don't need as much heat shielding for it. And once you reduce all of these systems as well, you're going to have fewer malfunctions because it's a simpler craft. So all of a sudden it really starts to make sense to go with something more like this. Also, remember, weight is key. The Russians, Soviets at this point in time, had rockets that could lift a lot of weight. We did not have that same capability. Our rockets could not lift the same weight that the Soviets could. So we needed to make things lighter. And the lighter we could make it, then we could start using the rockets that we had. And the Atlas was really what they were pushing towards, using the Atlas with a capsule on it. So eventually they used the Redstone just for suborbital flights. But the Atlas had the capability with something that was like this and lightweight to get it up into orbit. And that was the key. So 1958, NACA meeting on high-speed aerodynamics. And our friend Max Faget presents a paper on it. So that has to do with the small one-man capsule. And that is what ends up getting chosen as the route that they're going to go with the human spaceflight program. In 1958, a couple other things happened, and we'll talk about that here in a second. So John W. Jack Boyd, Senior Advisor for History at the Ames Research Center, said, had we not started doing this work at NACA before 1958 because we were curious, we would never have gotten to the moon when we did. In other words, they were doing this research because it was of interest, not because there was a president or Congress saying, figure this out. NACA was curious to figure out how we could do it because they knew that it was coming. So in any case, in 1958, NASA gets created. July 29, 1958, an act is signed off by President Eisenhower. They begin their operations in October of 1958, and they absorbed the NACA whole. All 8,000 employees of the NACA all got absorbed into NASA. So here, memo, November 5th, 1958, subject, Space Task Group. Effective this date, a Space Task Group reporting directly to NASA headquarters is established at Langley Field, Virginia, Langley Research Center, to implement a manned satellite project, a human spaceflight project. So, Mr. Robert Gilruth has been appointed a project manager. Remember Bob Gilruth, who's the assistant director of PARD with NACA. The following Langley Research Center employees are hereby relieved of their duties and assigned to the Space Task Group. And Max Faget from PARD. So, he's one of the first 35 people that get put into the Space Task Group as part. So one of the first 35 people that's now working for NASA on human space flight. So he was there at the very beginning, very obviously because of what he figured out research-wise already on spacecraft design and the Mercury spacecraft. So they name it Project Mercury, Messenger to the Gods. So we build a capsule eventually. So, and the Faget's involved with everything that's going on with the capsule. He's in charge of essentially the spacecraft design for it. Certain things he actually designed, other things he was just in charge of overseeing the design of. And you'll see here in a second, but the patent for the capsule, the patents for the escape systems, the patents for the cushion seats, etc., all these things, and he gets those as well. He has a ton of patents. But he's involved in all the decision-making for the Mercury capsule. So he's also involved in testing for the Mercury capsule. That's him, with a suit. Capsule system. So they know that one of the differences is if you have that pointy body coming in, you're going to actually have less G-forces as you come into the atmosphere. Higher heat loads, less G-forces. When you come in with a blunt body, you're going to have higher G-forces that you're going to be subjected to, and for a longer period of time. But that allows you to decrease that heating. So it's a give and take. They figure they're going to be pulling, the astronauts are going to be pulling up to about 8 Gs for periods of time during the load. So they know they're going to need to design seats for the astronauts. Well, once again, you can make it a really safe, really bulky seat that's really heavy, or you can try and figure out how to make a lightweight seat that will do the exact same thing. So Max Faget actually works on designing and creating the cushioned seats that are actually used by the astronauts. Lightweight material that's molded essentially to their bodies, etc. Every seat is custom fit to the astronaut that's going to be flying on the flight, etc. So he works on the hydrogen peroxide attitude control system, kind of steals it from the X-15, brings it over to the Mercury capsule. Retro rockets that are going to be needed to slow the capsule down so that it can come in and re-enter the atmosphere. The heat shielding, working on all of that. The escape tower, which we see right here. This was one of the genius things they looked at, because originally they were looking at solid rocket motors attached to the capsule, etc. Figured out, or ejection seats was another thing that they were looking at for the Mercury capsule. The equipment was going to be bulky, heavy, not necessarily get it away as quickly, etc. So there are solid rocket motors in this, but the basic system essentially is a tractor motor that is up at the top here. And then whether it's done manually or automatically by the system, when everything happens, basically there's explosives that separate the capsule from the rocket body very quickly. This lights off, pulls it up and away and off to the side. It separates, and then the capsule comes back down to a parachute landing somewhere safe away from the pad. Now, yes?
Do you have one of those capsules outside?
We have what we've got down there is a Mercury capsule. It's the one that you can walk up and climb into. It is not a real Mercury capsule, but it was built by NASA back at the time when they were trying to sell the Mercury program to the United States, and they traveled that capsule all over the United States for people to get an idea of how big the capsule was. That was the idea. So it is from the era, but it's not a real Mercury capsule, it's a replica. In any case, though, the escape tower here would pull the capsule away, come back, parachute. Thankfully, we never had to use it during any of our programs. In Mercury, we had this system. In Apollo, we had this system. In Gemini, we had ejection seats, and Max fought that like crazy. He hated that concept. He never thought that it would truly work if there was an emergency because of the angles and etc. Regardless, he got overruled on that one. The interesting thing is we never had to use it, but the Soviets did one time. They stole this concept. All you have to do is take a picture of it, and the pictures were out in the open press. Look at it and go, that's a decent idea. Let's go ahead and put that on, and they did. So I will say here is where they were testing the Mercury capsule up on top of rockets. They would launch the rocket off and then test it to where the system would actually pull it away, because it could pull it away on the pad, it could pull it away in flight. The little Joe 2 that we have out here was the same system as this, basically, that was used for the Apollo program. But these were the Mercury shots, and these were done not here at White Sands Missile Range. These were done at Wallops Island. This is the Mercury capsule. This is MR1. And anybody know what happened with MR1? Dave?
The one time it actually fired was quite embarrassing. The rocket rose a couple of inches, settled very neatly back in the launch pad. The escape system fired, and the rocket flew away and left the capsule behind.
Yep, it was a failure of the system, to say the least. But that's why we test things, So, in any case, though, and then they had the fun of trying to figure out how to deal with the rocket that was still there, fully loaded with fuel, and in any case. That's a fun lecture in and of itself, that entire incident. So that was the only time that we truly fired it on the launch pad. And you can see here it's kind of lifting away. Okay, on the other hand, like I said, the Soviets actually did use the system one time. I invented the escape rocket, and you guys saved a crew that way. And I never got a Red Star medal for that. He said that too. I do have to look up the name of the crew members. I've just blanked on them. That's why sometimes you write stuff down just so that if you forget, you can look it back up. Vladimir Titov and Gennady Strekalov. So in any case, though, it was in September of 1983. It was the Soyuz T-10A mission. These are actual pictures here from the explosion on the pad. Basically, the fuel system ruptured, started leaking, and then one of the turbo pumps had fuel coming into it. It spun up, it spun out of control, high speed, causing essentially mechanical failure, sudden mechanical failure and breakdown, sparks. It starts to explode. The cosmonauts just, something ain't right. They feel this is about 90 seconds before launch. is when all this occurs. And then what's happening down here burns through the automatic systems, burns through part of the manual systems. They had to do a key ejection kind of thing, and eventually pulled it away. You can see how far the explosion's gotten by the time the ejection system that's up here starts to pull the capsule away. But it did pull them away. It did pull them far enough away. They parachuted down, landed safely. The 2 cosmonauts actually got a medal from one of their retired friends, and actually did present it to Max Faget themselves. So, in any case, he did get his medal eventually. So, in any case, though, here's Max with the Gemini spacecraft. Just kind of some pictures of him during the era. Here's the designs. You got to submit stuff for the patent office. So, lead on it, Max Faget. You can see there are other names. Remember, he was leading a team of folks that were working on this. Some things he was doing individually. A lot of things he was overseeing as part of the team. I love this. From 1962, December 4th, from Bob Gilruth. Inventions and Contributions Board. Monetary awards for Project Mercury inventors. They got money. So, vehicle parachute equipment jettison systems. This guy got $1,000 for it. Emergency ejection device. $1,500 to be split between Max and another individual. Survival couch. Remember the seats that I was talking about. Max Faget and a couple other guys. They split $2,100. And then the space capsule itself, the entire thing, $4,200 Max, and then 6 other individuals. And if the rate of inflation from then to now is about multiplied by 9. So $9,000, $18,000, and then $36,000 essentially equivalent was split between those folks as a little bonus, saying thank you for designing our spacecraft. So eventually, NASA, the Space Task Group is there in Langley, Virginia, and that's where they run everything out of. All the design, the astronaut offices, the headquarters is in D.C. So, but the human space flight is all run out of Langley. But they know early on that they need another location. So in 1961, they start working on it. Eventually, they move into the new Manned Spacecraft Center in Houston. Haha. Houston. That's what we're used to hearing. So he becomes the Director of Engineering and Development. Here is the Manned Spacecraft Center organization chart. You can't read it from where you're sitting. So key thing being Director up here, Bob Gilruth, and the line's missing because of the way this thing was scanned. There is a line that comes right down the middle here. So, and then you've got Assistant Directors for Flight Ops, Chris Kraft. You've got Assistant Director for Admin, so I'm not going to bother. So Flight Crew Operations, Deke Slayton, who was a Mercury astronaut, and then Engineering and Development, Max Faget. So key individual within the organization of the Manned Spacecraft Center. So when they start pushing towards Apollo, they have a number of engineering issues to figure out. And the first things that they're figuring out is, do you do a direct ascent? You fly straight towards the moon, you launch, you fly your rocket and everything you need straight to the moon, and then you land on the moon. Or do you do an Earth orbit rendezvous where you launch pieces up, you assemble them, and then you fly on your way onto the moon, and then you land on the moon? And then eventually, John Hubble really steals the idea and proposes it to NASA, and eventually it ends up getting chosen. As far as the lunar orbit rendezvous, which is you launch your rocket and everything, you fly your way to the moon, you separate your pieces around the moon. One of them goes down, lands, comes back up, joins up, and then they fly back together. So instead of having the rendezvous of your equipment around Earth, you have it around the moon. That's what NASA eventually goes for, because once again, it all has to do with weight. And there's a lot less weight necessarily to fly a lunar orbit rendezvous mission than there is an Earth orbit rendezvous mission, and way less than a direct ascent. Interestingly enough, though, Max Faget pushes it first. What does he want? Direct. He wants the direct mission. So there are simplicity factors to that, but the weight ends up truly overriding it. He and John Hubble didn't get along in any way, shape, or form. They actually butted heads quite a bit, and it actually created, the guy who wrote George Lowe's biography, he gave me a bit of insight of stuff from his research that he'd found out. The other one had to do with the lunar orbit rendezvous choice. Lowe once said that he learned the valuable lesson of avoiding myopic thinking and failing for the smartest man in the room fallacy via Max Faget. When Hubble was making his initial noise about lunar orbit rendezvous, Lowe sent Max to investigate and let him know the merits as Max and others were for direct ascent. So Max came back completely against lunar orbit rendezvous, mainly because he supported direct ascent. He told Lowe, as he told other NASA leadership, that Hubble's figures lie. That's a direct quote. His figures lie. And that, quote, he doesn't know what in the hell he's talking about. Since Lowe knew Max and didn't know Hubble, he sided with Max. Quote, and this is from Lowe, none of us were smart enough to question him hard enough on it, Lowe recalled. It was a mistake on my part, not Max's, for not probing further, getting more inputs, and turning Max around to Hubble's idea. Which is eventually what happens. They do get everybody there turned around. But that was, I will tell you, there was other observations that, Max Faget, this is one of those things, he could be a difficult person as well. Very difficult. A lot of times with very smart people in organizations and stuff like that, they can be a bit of a pain at times as well, and Max was at times. In fact, Lowe also he was one of those people who was like, a meeting starts on time, it ends on time. We don't have long meetings, which is what he kind of held to up until the Apollo 1 fire. Then they had some longer meetings, but in any case, though, it was always he wanted to start on time. Well, guess who kept showing up late to his meetings? Max Faget. And so he got so ticked about it that finally, at one of the meetings, he stationed a person by the door, and right when it turned time for the meeting, he said, lock it. They locked the door. Faget shows up and starts screaming, at the door or whatever so, and Lowe just ignored him. They went on with the meeting. But interestingly enough, who was never late for a meeting again? Max Faget. So, one of those funny observations from within NASA. In fact, he actually got in trouble also and there's some letters that are in the presentation about disagreements with the scientific folks, who wanted to have certain science done on the missions, and and how that dealt with what was installed into the spacecraft. And he was pretty blunt about stuff and had to get kind of slightly reprimanded by, because it became public knowledge, that some of this stuff was going on and who talked to whom, etc. So in any case, though, there's some interesting reading about that, memos and stuff. Whenever this lecture gets posted online, you can read the memos inside the presentation. Bottom line being is that, you can be a difficult person and still be incredibly successful and get the job done. Just look at George S. Patton. Kind of thing. So hard to work with, but got the job done. So in any case, though, Lowe was like that Faget was like that as well. There was a little bit. The problem that came up there was that he was for direct ascent, and everybody thought he's the spacecraft designer. He knows everything. Well, eventually they figure out it's going to work better this way, and so everybody eventually comes to that conclusion. That's the route that they head down, and yes, he does end up heading up everything for the design of that spacecraft, etc. But in any case, though, this was one of the direct ascent concepts. Martin 410, you can see the huge size of it, etc. So, escape system, I just wanted to kind of mention, there's the actual, this is one of the little Joe 2 rockets, like we have out here, Apollo spacecraft, and then the tower for pulling the spacecraft away. Stayed hands-on throughout all the program. This is he, and that's Frank Borman. It's tough to tell there because it's kind of fuzzy. Inside the capsule, as they're looking at what happened in the Apollo 1 fire and trying to figure out, okay, what went wrong, etc. So this was part of the research that they were doing. So, selling the program. These are just some contemporary pictures of him in the air that I want you to be able to see. This is this is a Korean delegation, and he's explaining exactly how the entire Apollo spacecraft works to them. You can see the Manned Spacecraft Center buildings in the background there in Houston. These are those memos that where basically Bob Gilruth had to write a little bit of note and say, hey, we want everybody to work nicely together. Stop doing what you're doing. So He was there when the celebrations came in, so you've got everybody in here. So with George Lowe, Chris Kraft, Bob Gilruth over here. You got Max right here. So, I mean, when you talk about the key individuals, so he was there when Apollo landed. There at other times during the Apollo program, STS-2. This is during the Shuttle program, so he retired right after STS-2. So this was right before his retirement. So we're going to transition here really quickly. The next thing that he was involved with was what next? So what after Apollo? And so while Apollo is still going on, they're while Mercury is going on, they're figuring out Gemini and Apollo. While Gemini's going on, they're figuring out Apollo. While Apollo's going on, they're figuring out post-Apollo. It's all of that. These are just some of the concepts that were getting worked on. Big Gemini right here. So essentially a Gemini spacecraft. But then add in, you can take 12 people on this extended thing, and you could attach also back here with almost like an Apollo service module, a little laboratory back there. So these are, like I said, these are the concepts that they were looking at. So here's a model of it built. There's the essentially Gemini Capsule, where you'd have the command pilot and the pilot, because you can't have you can't have an astronaut that's not a pilot, right? So. In any case, though, and then space back here for the rest of the crew, at least initial concepts for it. So the Big Gemini final proposal, August of 1969. It's a month after we landed on the moon. That's just to kind of put it in time perspective for you. So Big Gemini with like I said, there's that concept of like a service module section in the back of it that could be a space station of some sort. They were working on space station concepts as well. With the Big Gemini here, there was a concept to put a stage of the Saturn IV out there, connected with wires, and spin them like this. So there was a wire connecting the two. Why would they do that?
Artificial gravity.
Create artificial gravity to make it easier for the crew. So in any case, so they were working on boost ideas like this. All of this is still in that concept phase. So remember what they were doing at NACA before NASA was even created. Now we're doing the same sort of stuff at NASA to figure out what's going to get proposed to Congress and the administration for what NASA is doing after the Apollo program. Just some more pictures of the Big Gemini concept. The other thing they were looking at was a reusable spacecraft. And so there were ideas for the reusable spacecraft that had to do with both capsules, but most of them really had to do with winged craft. And here he is with the initial model that, remember, model builder? Okay, here's a model he built. And here he is throwing it and dropping it. And he used to come up with concepts, and his kids talked about this. He'd be out in the backyard. They had fun with it. He would throw these things in the backyard that he created, these different shapes, designs, etc. They'd retrieve it, bring it back to him. He'd drop it. They'd retrieve it. He'd have them throw it, all sorts of things like that. They had fun with it doing that. But, this obviously is a little bit more formal here. Oh, by the way, see the bow tie? He wore bow ties all the time. It's one of the things he was known for. In any case, though, here he is holding that concept because this concept eventually was what the shuttle becomes. So obviously we're looking at it going, I don't know what the shuttle looks like, but this was the conceptual phase of it. If you get a chance to go to Kennedy Space Center, they have, in my opinion, by far the best display presentation of one of the retired shuttles of anywhere where they are. There's one out in California. Now, eventually California may overcome because California's building it. They're going to put a whole shuttle vertical with the full stack alongside of it of the tanks and the solid rocket boosters and everything. You're going to be be able to go up there at the height of the cockpit and everything. That should be pretty cool when they get to it. Right now it's sitting there like this. At the Smithsonian it's sitting there like this. The Enterprise is sitting there like this. But when you go to Kennedy right now, you go in and there's a pre-show that tells about this, how this was done and the concept of the shuttle and the model and everything. And then you go into the next area and it's the pre-show, and it's another video where it tells about the history of the true flying shuttle, and especially the one that's there. And then at the very end of it, I'll just tell you, if you're not almost in tears at the end of this thing, you're barely human. Because what happens is they finish up with the video and everything's flying by, all of this stuff about what the shuttle did, the history of it, and there's a garage door in back. What you don't know is that there's a perforated screen in front, And that's what they've been showing everything on. And similar to our dome, which is perforated, you show a movie on it, you can't see the other side of it because it's dark. So when the garage door is down, it's dark, all you see is the movie. Well, eventually the garage, as that video is going, the garage door comes up, and in the video there's the shuttle there, but then all of a sudden that fades out, and you're looking at the real shuttle in that exact configuration in front of you, nose on, like this. It's stunning. It's stunning. So, and then they have a ton of stuff about the shuttle. So in any case, I digress. That model is also on display there at that, and I'll show you. There's the picture of, there it is on display. There's a slightly closer look at it. It's a little worse for the wear over the years, but still in pretty good shape, all things considered, considering this was done in the 1960s. Space shuttle concepts. Remember I said there were capsule concepts. There's a whole bunch of other stuff. So the one that Max was really pushing to begin with is really kind of this one right here, or concepts like that, what he called the DC-3, and we'll get into that here in a second. Based on the old DC-3 aircraft. I should have chosen a better picture, but okay. In any case, though, and here are, April 1970 down to September 1970, different concepts. You can see there's a carrier craft, there's a shuttle portion. You can see it's got straight wings. What we know we end up with essentially is a delta wing on the shuttle. Once again, what does that have to do with? Heat loading, etc. A lot of the concepts and what the shuttle was heading towards and the designs for it and why it ended up the way it did was that the NASA needed help with it, and they needed to get the Air Force on board. So they got the Air Force on board, but some of the Air Force requirements were, what could it do, how far could it maneuver off of, you got an orbital path that it's going around the Earth. Well, how far off of that orbital path could it actually land? And they were wanting it to be 1,600 miles off of that orbital path. Well, that adds a lot of control, that determines what sort of design you have, wing shapes, everything else. And so that kind of overrode. There were some advantages to this concept, but it couldn't do what the Air Force wanted. In fact, actually, this thing only had that maneuverability of about 300 to 400 miles. So in any case, these are some images. I love that one. It's like, yeah, try launching that into space. It's like trying to launch a super guppy into space. If you've never seen it, if you're down at the El Paso airport, you can see the super guppy as you're taxiing on the runway. That they used to, the nose opens up on it, and they could load equipment into it. Had the massive nose on it. There is a NASA facility down at the El Paso airport. There's Spaceport America in the background there. Now, diagram done in 1969, though. Remember, they're working on these concepts very early on. This was kind of a modern computer rendition of the same concepts. Here you have it up in space, flying up to a space station. These were, once again, patent applications for the design. That was kind of funny. Somebody just took a DC-3 and made it look like a NASA thing, because that was, the concept. I love the propeller engine, and the propeller engine essentially almost doesn't look like there's one on that side. There is, but it almost looks like there's not. So these are some of the, once again, the conceptual stuff. This was all going on in the 60s and 70s, early on, as they're trying to figure out. Now, what was really going on is NASA knew that the Apollo program got cut off before they could fly all the missions they wanted to. We were supposed to fly another 3 missions beyond Apollo 17. 18, 19, and 20 all got canceled. In any case, though, budgets were becoming a big thing. It was no longer, NASA can have all the money it wants because we need to get to the moon. You got to the moon. Great. Now what's the next thing? And they needed to figure out what would sell. So initially, the proposals were, how many, billions of dollars per year could they get to do the programs, and at the top of the list was build space station, reusable spacecraft, deep space missions that were, something on the mark. That was $8 billion per year kind of thing, and, Congress was like, nope. So then you lop off part of that. Now you're down to $4 billion per year. Now you lop off more of that. You're down almost to like $1 billion per year. It kept going down, and that drove a lot of what happened here and what we eventually got. The Apollo applications program just turned into using a few old stages of the Saturn and putting up a space station, and the Skylab program, and the shuttle moved along, and it didn't move along at the pace that they were thinking because the money wasn't being put into it. etc. So it took much longer to get the space shuttle out where it was, and it kind of ended up being a hodgepodge as it was created. This is eventually what we get, very obviously. Once again, though, Max was the head of that design division, so people were working on individual parts, but the overall design was what Max was in charge of throughout this entire thing. So, and once again, heat loads come into effect. You know, the way that they did the tiles and the shielding, blunt nose, everything. You know, so a lot of the concepts you think about from the past come into play with this. They obviously don't use a reusable capsule. They end up using essentially a space plane. He retires in 1981 from NASA. This was a drawing that was done by somebody in the office there. This was what was on the press release for us as well. Some fun stuff in there. The patent vault for him to be able to have all of his patents. The auxiliary engine, the Mach meter here because he had worked on that one. So he loved LSU sports. There he is. He's got the TV showing Mercury Capsule original plans. Jet propulsion, the basics, his days at NACA and Mercury Capsule. All these different kind of fun things on it. But interestingly enough, up here, Alamogordo Space Museum. There was a legend that they did that listed out all the points of interest on the drawing. You know, that's actually on the original copy of this drawing. Everything gets listed out, what it all means, except for one thing. The flag with Alamogordo Space Museum. So we don't know exactly why it's there. Because he wasn't inducted here until later. So, in any case, so we're not exactly sure why that got up on there. So, but it's kind of fun. Yeah? So, Chester Bond, NASA Chief Engineer for the ISS. We considered him the father of our organization. He always had new ideas. And that's the key thing, is that, you know, regardless of whether or not he was right or wrong, he was thinking of new stuff. And he was a lot more right than he was wrong throughout his career. After he retires, he goes to work for Eagle Engineering first, does that for a period of time, and then he founds Space Industries Incorporated. They work on a number of things, but a couple of the biggest that are more known. He tried to get this sold to the government, the Industrial Space Facility, essentially a laboratory that could be carried up by the space station, operated space. Space lab, same basic concept. Model of it right here, pictures and images with the solar rays out. Back here you can see a model of it behind him. There's all the engineering drawings to give you an idea of size, etc. Okay, the other thing he works, and by the way, the ISF never flies, so it never gets beyond the conceptual phase. Nobody buys off on it. Wake Shield Facility, though, something else they worked on, this did get picked up. And so the Wake Shield Facility, and this is where we get into a bunch of engineering that I'm actually going to have to make sure I have my notes out for this section, just for this one little bit here. So the diameter, just so size-wise, it's about 12 foot in diameter. You can see it here being loaded into the payload bay of the shuttle. In case you didn't know, you see a payload bay here for the shuttle, but you don't see a shuttle. Payload bay is a separate component. You can get up and then eventually you put it into the shuttle. You can pull it out of the shuttle, etc. So it can be worked on separately from the spacecraft itself. You see it was deployed by the robotic arm here. It was released, and then it would fly off on its own to about 35 miles. Make sure that's right. Yep, 34 miles aft of the shuttle. You're about 190 miles up here. By the way, that's Florida, down there in the below it. You're up in the thermosphere, and this thing was flying about 3 to 5 times faster than the speed of all the molecules up in the thermosphere. So if it's flying faster than that, it creates a wake behind it, and inside of that wake, it creates basically a super vacuum behind it. It creates a vacuum, no molecules, nothing in there. What that allowed them to do was work on the studies of epitaxial film growth. Semiconductor work. Essentially what this allowed them to work on. Photocells, thin films, creating of those things in an ultra-high vacuum in the wake of this. They'd leave it out there for a couple of days, then the shuttle would rendezvous with it, they'd grab it, put it back in after the facility, the little mini facility, 12-foot diameter, did all of its work. It led to a whole bunch of advances in the semiconductor industry. Also things, artificial retinas. The thin films for artificial retinas came out of this concept and the research that was done on that. So that was actually successful. Did fly on 3 shuttle missions. 80 was the last one, so 94 to 96 was when it flew. Eventually, here you get just kind of an interesting thing. Burt Rutan there, and there's Max Faget. That's Buzz Aldrin right there, and Spaceship One here. So with the X Prize and the work on that one. One last thing to finish up. Max Faget. We're going to build America's next spacecraft, and it's going to launch like a spacecraft and land like an airplane. That obviously was right when they started working on the design for the shuttle program. Just a thought, Earth is the nest, the cradle, and we'll move out of it. Always a little sci-fi quote there for you. So, fun picture. That's flying now, all around Mars. So, and then I always finish up with this one. Questions?
Why is it that the orbital assembly around the moon in Apollo was lighter than just getting in the Earth orbit and then assembling it?
If you have a single craft and you're flying to the moon, it's what you land on the moon. If all of that has to land on the moon, then you have to have a pretty good-sized craft.
No, I get that, but I mean, they had the lander and the command module. Why didn't they separate it in Earth orbit instead of wait till they get to the moon?
The lunar lander itself had to keep it as light as possible so that it could get down on the moon, do the mission, etc. Had to keep it incredibly light.
Yeah.
And so you're not going to have space for, you remember the Apollo command module had the living part, that little tiny gumdrop at the top, and then had a huge service module behind it that kept all of the stuff in that would keep them alive for the flight to the moon and the flight all the way back. That lunar module was only designed to last for a few days.
Right.
And then it would be dead. Couldn't carry enough fuel or anything else. And so if you can't carry all that stuff, in your sole craft to fly all the way to the moon, land, and then come all the way back, they needed everything in that service module to live. And if you assemble it all on Earth and you fly it to the moon and you don't have a lunar orbit rendezvous, in other words, you just go down to the moon, you're basically just going to, your service module can't land on the moon.
Well, no, that's not my question. I'm wondering why you're going to have the two components, and one component, the lander's going to land, it's going to come back up.
But that's lunar orbit rendezvous.
Right, but why did they not just, once they get in Earth orbit, separate the two rather than...
And then have the lunar module itself fly to the moon and land.
No, both fly to the moon, but didn't they, in lunar orbit, have to do this incredible maneuver and turn it around and then...
Come up to me afterwards, and is there anybody else who has the same or not understanding what I'm saying? Because I think I need to give a slightly different description, and I'll have to do it probably with a drawing, kind of thing. So the bottom line being is that Earth orbit rendezvous had to do with, essentially, you took multiple pieces, you flew them up there, you hooked them together, then you flew to the moon, and all of that landed on the surface of the moon.
Yeah.
Which was pretty heavy.
Right.
Heavy, because all of your service module components. So you had, your lander was not just the lunar module, it was everything. The stuff to keep you alive for all those days. All of it had to land on the moon. That was very heavy, and trying to get off the moon was really the difficult part of it. Whereas with lunar orbit rendezvous, you flew up your two components, same thing, you flew them to the moon, then you separated them. Now the little tiny light thing could land, come back here, separate that, and then the heavy part comes back. That heavy part was the key thing. The heavy part was what keeps you alive. If you did direct descent, everything went really heavy.
Right.
If you did Earth orbit rendezvous, you could launch two smaller things, hook them together to make the heavy thing, fly that to the moon and land. But with lunar orbit rendezvous, you launched up your heavy thing, sent it to the moon, and then it separated into a light and a heavy thing. The light went down to the moon, heavy came back up here, you got rid of that, and then you came back in the heavy thing to survive in.
Right.
It was all the weight, and those are the three options. So the first two, all of the heavy stuff landed on the moon, and it wouldn't work.
Yeah.
Any other questions? Yes?
Didn't Werner von Braun have a suggestion for getting to the moon? Was that discarded? Or?
Well, he was looking at landing at the moon, early on, and moon and Mars, from the very start. That was his goal, really, was Mars, was getting to land on Mars. So yes, he had concepts too. In fact, he was actually in favor of direct ascent. Was what he wanted, and what he was designing. You go back and look at those original designs that they were looking at there at Marshall. Massive spacecraft. So, but that's what they figured out eventually, is that was too much weight for them to get up there. Too much weight for them to be able to lift. Even the Saturn V couldn't lift what you would need for a direct ascent. And the Saturn V was a big rocket. Really big one. Anybody else? Yes?
On that note, why didn't they just wait until they could get a rocket like the Russians had to support weight and go with direct descent, and then they would be that much closer to Mars?
The Russians did build a massive rocket at the N1, and the Russians figured out as well that direct descent.
Okay.
Their thing also had, guess what? Essentially a command module and a lander as well. Their lander was bigger because their rocket was supposed to be able to lift more, the N1. They tried to launch the N1 4 times. All 4 of them blew up.
So it was never.
Never made it off the ground. The problem, they had 32 engines on the bottom of it, and trying to control all 32 of those engines simultaneously with the technology they had at the time, and it was Russian technology, which wasn't anywhere near as good. There was always the system ate itself essentially every single time. So nowadays we're launching rockets. Musk is launching rockets with 3 Falcon 1 first stage things there that have 9 engines, so 27 engines. Different control systems nowadays, though, they can do that. So with smaller engines. Yes, sir.
On one of them letters there that you had shown in your slideshow had James Webb. Mm-hmm. Is that the James Webb?
Yes, yeah. That the telescope is named after. That's out there right now, very successfully making its way out to the Lagrange point. In fact, if you don't know, James Webb Space Telescope launched last month.
Christmas Day.
Oh, sorry. I was like, all I heard was Chris.
Oh.
So I was like, what? So sorry. In any case, though, and it's on its way out to the Lagrange point. Lagrange points are null gravity points that have to do with the Earth and Sun, Earth and Sun and gravity points, etc. In any case, though, so it's on its way out there. Once it does, it will deploy, and we won't be seeing a lot further out than we used to be able to see, even with the Hubble telescope. So it should be absolutely phenomenal. So, but everything has worked perfectly so far. Yeah. So, because everything does have to work perfectly, or that's a lot of money down the tube. So, yeah, but that is the same James Webb, NASA administrator, et cetera, et cetera. Yep. Anybody else? Yes,
Sorry,
ma'am.
one more question. What goes on at the NASA facility at the El Paso airport?
It's a flight maintenance facility. So aircraft maintenance for NASA. So there are they have a lot of T-38s and things like that. So all of those aircraft, when they need maintenance, they bring them here to El Paso, and they do maintenance on it. It used to be also where they kept the shuttle landing, or the shuttle training aircraft, the STAs. Used to be based out of there as well, and they would keep them up. So, and the STAs were used. The aircraft, they could fly it like a regular aircraft, and then they could flip a switch, and it essentially degraded the aircraft's performance such that it would then operated like a shuttle would, which is essentially a glider. And so basically it turned into that. And they used it to practice landings at Kennedy, out at Edwards Air Force Base, and out here at White Sands Test Facility as well. The astronauts came here before every mission and trained on the SDA out at White Sands Missile Range. I think I said test facility before, but actually the missile range. Any other questions? Thank you for joining us today. I think Kathy has a couple of announcements here. We'll get through those.